During space travel, a single mathematical error that may seem insignificant could lead to devastating consequences. What if I told you that there was a mathematician so precise that astronauts at NASA refused to launch without her calculations? That was Katherine Johnson. She was a mathematical genius whose work made the idea of safe space travel a reality. Her calculations ensured orbits, landing, and returns were safe long before complex computer systems could be trusted. Her work shaped one of NASA's most important space missions, John Glenn's orbital flight back in 1962. However, Johnson's contributions are not just about math. As a black woman in the 1960s, she overcame the barriers created by racial and gender inequality to become one of the most important mathematicians in history.
Today, we are going to focus on how Katherine Johnson used mathematics to improve space travel and inspire diversity in the fields of STEM. Johnson specialized in orbital mechanics, the area of mathematics that deals with how objects move in space. One of her most significant achievements was determining the way in which a spacecraft could stick to a particular pathway while traveling in space. The first key mathematical concept that she was involved with is elliptical orbits, which are oval-shaped paths in which planets and spacecrafts travel. This phenomenon is described by Kepler's first law. Johnson used the equation of an ellipse, x squared over a squared plus y squared over b squared equals 1, in which a represents the semi-major axis, the longest radius of an ellipse, and b is the semi-minor axis, the shortest radius of an ellipse. She used this equation to ensure that John Glenn's spacecraft, Friendship 7, could orbit Earth correctly and re-enter at the precise angle. The second mathematical concept that she was involved with is re-entry angle calculation. If the re-entry angle was too large, Glenn would burn up in the atmosphere. However, if it was too small, he would skip off into space by moving out of the expected orbit. Johnson applied trigonometry to accurately calculate the correct angle required for an optimal re-entry. Specifically, she used the sine and cosine laws to determine how the spacecraft's movement through its orbit will be affected by gravity and air conditions. Her precise calculations determined the correct angle to be around 5.6 degrees. NASA's computers were quite unreliable at that time. However, her calculations ensured that the success of Glenn's mission and future Apollo flights, including the revolutionary moon landing in 1969.
Katherine Johnson changed the face of space travel and exploration forever. She relied on manual calculations to outperform technology and substantially reduce the number of errors that could occur. Through her work, NASA was able to conduct more precise and safe space travel, which revolutionized the world of astronomy and aeronautics. She was not just a mathematician, however. She was also a powerful symbol for resilience in the face of adversity. Her achievements prove that factors such as race and gender do not dictate someone's potential. Johnson had to work at a facility where black employees were subjected to segregation and other forms of discrimination, but she refused to be defined by the treatment she faced. She broke several barriers along the way. She became the first woman in NASA's Flight Research Division to be recognized on a research paper. Her actions inspired countless black women to pursue careers in STEM and overcome the discrimination that they face to achieve extraordinary things. Katherine Johnson didn't just do math, she was a trailblazer who changed history. She showed that brilliance does not have any boundaries, and her accomplishments prove that mathematics is a tool that could be used to drive progress, unity, and